All right, let's talk about power. Power is how fast you're expending energy or adding energy to a system. Since energy is measured in joules, and we're talking about how fast, that would be joules per second. So we define 1 watt to be 1 joule per second. Is a watt a lot of power? Well, imagine a robot arm taking a 1 Newton weight, moving it up 1 meter. That and taking 1 second to do it, so that would be a watt of power. That does not seem like a lot, right? Um, so we'll say moving a small apple up 1 meter in 1 second. Let's talk about how we actually generate power these days, or how we use it anyway. So the cost of electricity from the electric grid, you actually pay for the energy you use, not for the power. At least residential customers, people who live in houses and apartments and stuff. If you're a business customer, you actually pay for both energy and power. So talk to me about that sometime. So 1 watt is not very much power, right? And we use a lot more than that, so we tend to use kilowatts, but that's power. We need it in energy, so we kind of cancel the seconds by multiplying by a time unit. Hours is a more reasonable time unit than seconds for a lot of this. So we pay per kilowatt hour, how much is a kilowatt hour in kind of actual metric units? It turns out to be 3.6 megajoules. And does a kilowatt cost a lot? Think of a kilowatt hour. How much does that cost to buy from the electric grid? I looked it up. Care to guess what the answer is? How much do you pay per kilowatt hour? It turns out, depending on where you are in the country, it's anywhere between 10 and 20 cents. Last time I looked it up for Metro Detroit, it was about 17 cents per kilowatt hour. Running a hairdryer or a toaster oven takes a little bit more than a kilowatt, so leaving a hairdryer on for an entire hour costs about 17 cents. Let's think about how much power we're all using all the time. I looked it up for 2016 was the latest year I could find. In the US, we used about 12,000 kilowatt hours per person for the year. If you divide that down to the hourly stage, that's 1.4 kilowatt hours per hour, or just 1.4 kilowatts. And that we're buying that from the grid, so we're basically paying 20-30 cents an hour for our electricity. And that's not just in-home use, but that's like the power that the factories use to make the stuff that we then buy, I think is incorporated in this thing. But let's say we didn't have electricity and we had to hire people to do all the work. So how many people would I need to be doing the work necessary to do this? It turns out that a manual laborer, I looked this up, so someone accustomed to expending a lot of energy during a shift, can average about 75 watts sustained for 8 hours. Or at least averaging over the 8 hours. Some science museums have a electric power generating bicycle you can ride, and you try to light up light bulbs. And if you try to light up an old-fashioned 100-watt light bulb, an incandescent light bulb, it takes a fair bit of effort, and it would be hard to imagine actually doing that for more than a few minutes. So 75 watts seems reasonable to me. So here's a question. If we had to have people generate the power for us by riding stationary bikes, how many people would we need to generate the average amount of power? So we'd say 1.4 kilowatts divided by 75 watts turns out to be about 19 people. So imagine you have 19 people working all the time for you to generate the amount of power that we're using on average. Yeah, that would be power. So now those 19 people, they work for 8 hours, right? And then they need a rest. So you got to bring on another shift, and then a third shift. So overall, we're talking 3 shifts of these people. So it's turning out to be about, what, 50 to 60 people working for you 20 at a time, basically. But if you had to employ them, you would have to employ 50 to 60 kind of servants to give you the energy that we're using or the power that we're using on average all the time. So the electric power grid is, people say it's one of the most complicated machines in the world, and think of how rich we would have to be to afford 50 to 60 servants working for us like this all the time. I think it's a vastly underappreciated asset, and if you're looking for an industry to go into, I'd say the electric power industry is pretty important. Lots of really interesting math jobs going on there, and we're paying, what, 20 cents an hour. All right, next we'll talk about generating that using hydroelectric dams. Next video.